So let's go ahead and take a look. Okay, so we have 3 equations here. And the best thing I'm going to do is I'm going to try to get to whittle them down. So this is going to take a little bit of finagling. So I have 5x plus 3y equals negative 5z equals 3. So let's go ahead and get them down to 2 unknowns if possible. So I'm going to take this and I'm going to put everything over on the other side. So I'm going to have 5x equals negative 3y plus 5z plus 3. So what I did here is I just subtracted 3y from both sides and added 5z to both sides. If I divide everything by 5, then I get x equals, so divide everything by 5, negative 3 over 5y plus 1z plus 3 over 5. All right, sorry, didn't see that. So I'm going to take this x and I'm going to substitute this in for the other 2 x's. So then I will have everything just in terms of y and z. Then I will have 2 equations, 2 unknowns, and we'll go from there. All right, so now I have, this is going to substitute into this x and into this x. All right. Going to get a little bit more paper for this one. So, first thing we need to do, 2, and then x is negative 3 over 5y plus z plus 3 over 5. And then go ahead and write everything else. Minus 5y plus 2z equals 11. All right, and let's solve this. So I get negative 6 over 5y plus 2z plus 6 over 5 minus 5y plus 2z equals equals 11. All right, so now I'm going to take the negative 6 over 5y and I'm going to add that with negative 5y. So negative 5y is just the same as, I need to have same denominator, so I'm going to call this negative 25 over 5 because 25 divided by 5 is 5, but I need the same denominator. So that's going to be negative 31 over 5y. And the z's, fortunately, there's no fractions on them, so that makes it easy. Plus 4z plus 6 over 5 equals 11. Let me go ahead and move that over. Sorry, I should have done that. So if I subtract 6 over 5 from that side, 6 over 5 on this side. Again, let's call this 55 over 5. So 55 over 5 minus 6 is going to be 49. So that's going to equal 49 over 5. Now we can make this simple, and I can just multiply everything by 5 to get rid of that if we want to. So if I did that, I'd have negative 31y, because the 5 would cancel. 4 times 5 is 20z, and then that's 49. So that makes it a little bit prettier. Okay, we're not quite halfway yet. This is kind of a longer problem. So on number 8 here, if we look here and we look at the next one, we have to put it also into here to the 6x. So if I do that, I'll just do it down here. It's going to be 6, and it's going to be put into, remember, negative 3 over 5y plus z plus 3 over 5. And then I'm going to minus 4y plus 6z is what it is. Minus 4y plus 6z equals 44. Okay, so I'm going to go ahead and solve this. So I get negative 18 over 5y plus 6z plus 18 over 5 minus 4y plus 6z equals 44. Okay, so I'm going to do the same thing. I'm going to combine this y with this y, and 5 is the denominator, so I'm going to make this into negative 20 over 5y. So if I combine these two, it's going to be negative 38 over 5y. The 6z and the 6z is going to be plus 12z. Subtract the 18 over 5, subtract the 18 over 5. So I need 44 times 5, so what's 44 times 5? So that's going to be 0, carry the 2. And that's going to be 22, so 220. So this is 220 over 5. So that's all I did is I'd made 44 is 220 over 5 is what I'm trying to do, just to have the same denominator. So 220 minus 18 is going to be 202. So that's going to be like 202 over 5. Again, I can get rid of this 5, and I can go ahead and multiply, and I get negative 38y plus 60z equals 202. Okay, now we have this equation here. And we have this equation here. So using these two equations, now I've eliminated the x, and now I have two equations, two unknowns. And now you're going to solve this the same way that you solved everything else. I think elimination is going to be the easiest one on this one, so let's go ahead and do elimination on this one. Okay, so I'm going to take this equation and I'm going to multiply this equation. If I notice a 60 and a 20, if I multiply this one by negative 3, I'm golden, because then I've got negative 60, and when I add them, the z's will cancel. I'm going to multiply this one by negative 3, and I'm going to go ahead and put the answer down here. So negative 3 times negative 31 is going to give me a positive 93y. Okay? Negative 3 times positive 20 is going to give me a negative 60z, which is what I want, because I want these to be opposite, so when I add them, they cancel out. And negative 3 times 49 is going to give me negative 147. Okay, so remember we wanted them to be opposite, so I don't have to subtract. I'm just going to go ahead and add them since these are already opposite. So I get 93 minus 38, so I have 93 minus 38 here. And so of course I borrow, I get 13 minus 8 is 5, 55. I have to show my work when I'm on video because I tend to make mistakes if I don't, and I try to, and I don't have anybody to keep me accountable. If someone telling me I messed up. So 60 minus 60 is 0, and then I have 202 minus 147, and that's also going to be 55. Doesn't that turn out to be nice? All of that work. Goodness. And then divided by 55, of course, is going to be y equals 1. Yay! Okay. So now your answer is going to be written as x, y, and then z. So I got that one right there. So now that you have 1, you simply are going to take this 1 and you're going to put it back into one of your equations. So if I put my 1 back into this equation, then I do some math, I'm going to end up in getting x equals 4. So if I put negative 31 plus 20 times 1 equals 49. Oops, excuse me, negative 31 times 1 plus 20z equals 49. That's going to end up being, if I add that, it's going to be 20z equals 80, divide by 20, and x equals, oh, you can't see that at all, can you? X equals 4. Okay, so now I have x equals 4, y equals 1, so now I take 4 and 1, and I put it into one of my original equations, and that's going to get me z. And z is going to be 4. So those are the answers, 4, 1, and 4. So that's my x, that's my y, and that's my z. This one, by far, as you can tell, took a bulk of the time